Welcome guys to Odd Tech Reviews. On this channel, we'll be reviewing some of the odd and hard to find hardwares and see how they perform. Today in the first video, we're going to review the Intel CC150 processor that's customized for Nvidia Geforce Now. I apologize for the production quality of this video as my house got flooded during the middle of this project. I lost most of my equipment including the Elgato card. So I have to film the screen directly in this video, and there is some inconsistency in the audio as you can hear because those are recorded on different devices during different times. But the good news is the new stuff I ordered already on the way, so the production quality should be much better in the next video. I paid about 1880 RMB, which converts to about $270 US on Taobao.com. Today we're testing the C150 on the Gigabyte C246W4 motherboard. It is actually a workstation motherboard, however, it comes with features you will only normally see on a consumer motherboard, like premium audio, reinforced PCIe slots, as well as debug light. But it also comes with some workstation elements, such as an Asian PCI slot, COM ports, and LPT port. We'll be testing the CC150 with these Dell memories. Those are 8GB DDR4, 2400 MHz, ECC Unbuffered memories. Yes, the CC150 supports ECC Unbuffered memory, which technically makes it a Xeon instead of an i9. Now I've installed the CPU and the memories to the motherboard. For the cooler, we're using a knock to a low profile cooler. You'll find out why we choose this cooler later in the video. For the video card, we're using a reference GTX 980. And the interesting part is the SSD. As you can see here, it looks like a normal Intel Optane 800P series. However, it is actually an Intel Optane M15, which was cancelled last minute before it's released. We'll do a separate video on that. Please subscribe if you don't want to miss that video. The motherboard comes with two M.2 slots. The first slot near the CPU supports both NVMe and SATA. However, only at Gen 3x2, which would be a bottleneck for most high-end NVMe SSDs. The second slot only supports NVMe SSDs and has a Gen 3x4 speed. The first M.2 slot shares bandwidth with SATA 9 port when you're using a SATA M.2 drive. However, if you plug an NVMe SSD into the second M.2 port, it will disable the second PCIe by 4 slot, as it shares bandwidth with the M.2 slot. The motherboard looks nice with 4 PCIe X16 slot. But does that mean you can do things like 3-way SLI or 4 LSI SAS controllers? No. Although those are physical X16 slots, they do not come with full PCIe bandwidth. Here's a picture of the PCIe distribution from the Gigabyte website. But what does that mean? Let's say you plug in a video card into a first PCIe X16 slot, which you have to do in this case since this chip has no iGPU. Then, the second PCIe X slot will be automatically disabled because it shares the bandwidth with the first one. Okay, next, let's plug an NVMe SSD into the second M.2 slot, which shares the bandwidth with the second PCIe X4 slot. Then you're left only with a PCIe X4 slot and a PCI slot. There will be no available PCIe bandwidth left for, let's say, a SAS controller or maybe a fiber optic card, as those are usually PCIe X8 cards. However, it's not Gigabyte's fault. The Intel mainstream desktop CPUs only come with 16 PCIe lanes, so there's really not much Gigabyte can do about it. If you need more PCIe lanes, they have to pay a premium to get the HEDT platform, which kinda sucks. Okay, I've got everything hooked up, and now it's time to power this thing up. Okay, the code is running. B2. Okay, it restarts. Okay. B2 again. Well, this is taking a while. Okay, here we go. I finally post. We're in the BIOS screen here. You can see it's an F5 BIOS, which is the latest for this motherboard. And under CPU temperature here, you can see it's running at 26 degrees Celsius, which is even lower than the ambient temperature. And yes, this motherboard supports overclocking. So here, you can adjust the base clock, the multiplier, and also the memory frequency. As the CPU officially supports DDR4 2666 MHz memory, we'll overclock the memory a little bit. So here, let's type in 2666 without changing any timing and see if it actually works. Okay, here we go. Time for the magic. So the debug light is running, and well, this is taking a while, but it should be fine. Okay, let's go into Windows 10 and see if our memories are actually overclocked. Okay, here we are. Let's fire up some CPU-Z. So under the memory tab here, we can see our memory is running at 1333 MHz, which has the equivalent speed of 2666 MHz. So the overclocking actually worked. Next, let's take a look at CPU-Z information. According to CPU-Z, this processor has 8 cores and 16 threads. It's running at 3.5 GHz. However, if we take a look at the multiplier box here, it says 8 to 35. Yes, you're right, my friend. This processor does not support turbo boost. One interesting thing about it is instead of carrying an I badge, like an i5 or an i7, this processor only shows up as an Intel CC150. I've seen similar naming schemes only on Amazon AWS customized chips, like this one right here. Here is the CPU-Z screenshot of the chip. You can see it shows up as an AWS 1100 V4 at 2.4 GHz. So please comment below if you'd like to see a review of this chip. Let's compare the CC150 to other 9th gen Intel chips. So as you can see, it kind of falls in between the 9900 non-K version and the 9900K. The i9 9900 non-K version has a lower base clock, but it turbo boosts all the way up to 5.0 GHz. And the 9900K has a higher base clock and also turbo boosts up to 5.0 GHz. The i7 9700K also has 8 cores. However, it does not support hyperthreading and has a lower L3 cache. The closest Xeon variant I can find here is the Xeon E 2278G. It also has 8 cores and 16 threads. It actually has a slightly lower base frequency, but it turbo boosts all the way up to 5.0 GHz, just like the other i9 processors. However, it's much more expensive than the CC150, and I can't find them for sale anywhere online, not even on AliExpress. Just like the other 9th gen processors, the CC150 has a soldered IHS rather than a thermal compound used in the 8th gen processors. So let's start with the CPU-Z benchmark. On the right hand side, let's use HWinfo64 to monitor the package power consumption, the V-core, and the temperature of the CC150. Okay, let's get it started. As you can see here, even under full load at 3.5 GHz, the V-core is well under 1 volt, and the temperature is just around 44-45 degrees Celsius, which is super cool. Okay, we're almost done with the test here. As you can see, it got 404 points in single-threaded tests, and it got 4100-ish in multi-threaded tests, which is not very fast considering it's an 8-core 16-thread CPU. Let's take a look at the comparison. As you can see, it underperformed most of the other 8th and 9th gen Intel CPUs by 30%. The only CPU it could compete with is the i7 4790, which was released 6 years ago in 2014. In multi-threaded testings, however, it performs identical to a 9700K. However, it's still slower than the i9 9900K by almost 30%. Next, let's take a look at how it compares to AMD in this regard. So according to AMD, 3700X is the competitor to a 9700K, and the 3600X is the competitor to the 9600K. So as you can see in the chart, the CC150 underperformed both Ryzen processors by about 25% in single-threaded tests. However, in multi-threaded testings, it performs identical to a 3600X, while it is still 30% slower than a 3700X. Okay, next, let's try some Cinebench R15. And it's finally time to explain how I got a crazy score in a video thumbnail. No, it's not a clickbait. It's an actual picture, not a Photoshop picture. I guess the program ran into some kind of bug, and everything resumes to normal after I restart. Okay, here we go with the test. 3, 2, 1. It doesn't look too fast here. Okay, it's only got 1512 CB, which is pretty low considering this is actually an 8-core 16-thread part. But how does it compare to other processors? As you can see here, the result is actually very similar to CPU-Z benchmark. It performs identical to a 9700K, however it's still slower than the 3700X or the 9900K by almost 30%. Now comes the million-dollar question. Can it run Crysis? Well, since I focus mostly on server products, so I don't really have many high-end graphic cards to test with, nor do I have many games in my Steam library. So, instead of running actual game benchmarks, I will use 3DMark and PCMark to test how the CC150 perform in games. Okay, let's run the 3DMark TimeSpy benchmark. We'll run both the GPU test and the CPU test. Let's get it started. So here I'm running the test at 1440p, which is the native resolution of this monitor. I'm keeping all the settings to default. Let's see how it works out. Okay, here comes the result. So we got 4563 points, and we got 4210 on GPU part, and 8709 on CPU part, which is pretty normal for this kind of configuration. And the result actually looks pretty good here. The CC150 performs on par with other CPUs in its class. Let's take a look at the CPU temperature during the test. As you can see here, even under the CPU test, it is well below 60 degrees. And not to forget, we're only using a low profile Noctua cooler with it, which is truly impressive. Here comes a PCMark 10. Since we're only testing the CPU's performance in gaming, so instead of running the whole test bench, we're just going to run the CPU physics and the CPU and GPU combined test. Okay, here we go. Let's not talk too much about the score, as we already know how it's going to perform. Instead, let's look at some CPU temperatures. As you can see here, it's running even cooler than the 3DMark. The highest point here is only 45 degrees Celsius. Next, let's take a look at the CPU power consumption. Here on the chart, the highest point is actually 51.91 watts. If I remember that correctly, even an i5-9400, which only has 6 core and 6 thread, will consume a little more than that on a PCMark test. This makes the CC150 very impressive for its performance and power ratio. This is crucial for big data centers like Geforce Now. According to CoolestSystems.com, data centers use nearly 40% of its total electric draw just on cooling. So, less heat dissipation means significant saving for data centers. Lastly is the Prem 95 test. So Prem 95 tortures the CPU to its maximum capability and utilizes a lot of AVX instructions. So here we're running a small FFT test with AVX 512 disabled because the processor does not support AVX 512. Okay, and we're doing 16 threads since the CPU has exactly 16 threads. Okay, let's get it started. On the right here, we're monitoring the temperature, the CPU package power, as well as the V-core. You can see the temperature is going up a little bit. However, as you can see here, the package power is running all the way up to 81, which is the highest we've seen so far. And that kind of explains why this processor has a 95 watt TDP. Now here, let's talk a little bit about AVX. Typically, AVX workload will put much more stress on the CPU. All Intel CPUs, according to my knowledge, including the LGA 3647 Xeon scalable processors, have a lower AVX frequency than space clock, because running AVX instructions at high frequency would easily push the CPU over its power and temperature limit. This is especially true for high core count Xeon scalable CPUs. By the way, we'll have a video on overclocking a 18-core Xeon processor soon, so please subscribe so you won't miss that. Technically, the CC150 is neither a Xeon chip nor is it an iSeries chip. That makes me wonder, would it work on 300 series motherboard without modifying the BIOS? There's only one way to find out. So here we are. I've installed the CC150 on the Gigabyte H370 and Wi-Fi motherboard. And for the convenience, I'm actually using an Intel stock cooler. And we already know it's not running hot anyways. And as we know, the H370 does not support ECC memory. So we put a regular Crucial DDR4 memory to use it with the CC150. Okay, here we go. It powers up. The fan is spinning. Let's see if it posts. Alright, here we go. It posts with no problem. Now I want to try something even more interesting. Would it work with ECC memory? I've installed the ECC memories, the two Ballistix we used before. Let's see if it works. Yeah, it worked. Okay, now it's time to check if ECC is actually working properly. Let's open up Info64. Okay, run. Okay, as you can see here, it's recognized as a CC150 with no problem, and it's in fact running on an H370 motherboard. And the ECC here, yes, it's active. So that confirms my guess. Since the memory controller is integrated into the CPU rather than a motherboard, so it really depends on the CPU rather than a motherboard whether you can run ECC. However, that's given you can find a way to fire up a Xeon on a regular 300 series motherboard. As some of you may know, many high-end gaming laptops like Force are just rebranded Clevo systems, and many of which will take a desktop processors and a laptop chassis, up to 65 watts. Although the CC150 is rated for 95 watt TDP, but it stays well under 60 watt at 100% load under most used scenarios. So unless you're running heavy AVX workload for an extended period of time, I assume you can use these in the Clevo systems to achieve better thermals and better performance. But don't quote me on this though, as I don't have a Clevo system to test it with. Things start to get interesting here. If you think you absolutely need ECC support for your workload, but you do not have the budget to go with the LGA 3647 Xeon platform, which technically supports registered ECC. It's a different thing, but it functions the same. So the CC150 will be the way to go. Because instead of regular Xeon E processors, which only works on C246 chipsets by default, you can use the CC150 on a 300 series motherboard. And this has several advantages on both ends. If you simply need the most basic motherboard, but yet needs ECC support, you can go with as low as the H310 motherboard, which will save you quite some money compared to a C246 motherboard. Although not included in this video, I've tested this CC150 on MSI H10 motherboard, and it boots straight up, just like the H370 motherboard we test in this video. On the other end, most C246 motherboards are pretty basic, and do not come with many feature sets, such as premium audio, onboard Wi-Fi, 10GB network adapter, or Thunderbolt 3 support. If you need these feature sets and also needs to have ECC memory support at the same time, then you can go for a high-end Z390 motherboard, like the ROG Maximus or Gigabyte Z390 Design Air. Another possibility with the CC150 is to build a super compact mini ITX workstation with ECC support. Gigabyte and SRock Rack has C246 motherboards in mini ITX form factors. Even if you don't need ECC support, it will be ideal for a super compact mini ITX system thanks to its ultra low power consumption and heat dissipation in its class. So, conclusion. The CC150 is a nice choice if you need a cheap alternative to Xeon E processors, or need a cool and less power-hungry CPU in a super compact build. Being an 8-core 16-thread processor, it will be a good choice if your workload scales well between multiple processing cores and thread. However, most games will benefit more from frequency rather than a core count. So, if gaming is the only thing you do with a computer, you'll be better off with an overclocked 9600K. Not to forget, the CC150 processor is a Nvidia customized chip, and it's not intended for regular customer. They're not available through any major retailers and do not come with an Intel warranty. So guys, that's it with the CC150. It has specs of an i9, price of an i7, and thermal performance of an i5. Overall, is it good? I think you got your own answers. Since I'm doing YouTube part-time, I will try my best to upload weekly. Unlike larger channels like Linux Tech Tips or Gamers Nexus, we don't get sponsorships from manufacturers, and we have to purchase every product we review out of our own pocket. So if you like the video, please support us by hitting the like button and subscribe. You can also click on the links in the video description if you want to purchase any of the products mentioned in this video. We'll get a small percentage of commission from the retailer to cover some of our expenses. If you don't like the video, you can comment below to let us know how we could make this better. Thanks for watching.